Hello guys, myself Namita from Information Science and Engineering Department studying at Sri Venkateshwara College of Engineering. So the topic of today's video is Basis Path Testing, its guidelines and observations from the subject Software Testing 21 IS 63. Let's get into the contents of the video. Contents: Introduction, importance of basis path testing, its guidelines, that is guidelines for basis path testing, steps to performing basis path testing, advantages of basis path testing, challenges of basis path testing, observation during basis path testing, best practices for basis path testing, common mistakes to be avoided in basis path testing, tools for basis path testing, limitations of basis path testing, real-world applications of basis path testing, future trends in basis path testing, comparison of basis path testing with other testing techniques, key metrics for evaluating basis path testing, failure due to inadequate basis path testing, continuous improvement in basis path testing, and then the conclusion. First, let's get into the introduction. Introduction to basis path testing. Basis path testing is a structural testing technique that helps in creating test cases to cover all possible execution paths of a program. It is based on the control flow graph of the program. It helps in identifying the independent paths within a program's control flow graph. The goal of basis path testing is to ensure that all possible paths through the program are executed at least once. Next, importance of basis path testing. It helps in identifying logical errors in the code, provides a systematic approach to test the program thoroughly, increases the reliability and quality of the software. Then, the guidelines for basis path testing. Understand the control flow of the program by creating a control flow graph. Identify the independent paths within the control flow of the control flow graph. Generate test cases to cover each independent path. Next, these are the steps. Steps to performing basis path testing. The first step is to create a control flow graph for a specified code section. A control flow graph is a section of code displayed as a graph along with the possible paths that could be executed. Here is a simplified control flow graph for an if-then-else statement. The circles are nodes that represent blocks, and the lines connecting them are the edges which represent control flow paths. This is the second step. The second step is to select a baseline path through the code. This baseline path should be the path most likely used. It is also the most critical path to test, as it will be the foundation for all other test cases. Typically, a product manager will provide the baseline path labeled as the critical path. Next, the third point. Once the baseline path is selected, generate the second path by changing the outcome of the first decision. Remember, you are not necessarily changing every decision along with the path. The emphasis is on ensuring a different outcome after the decisions are made. The maximum number of decision outcomes should remain the same as the initial baseline path. Fourth point, generate a third path by changing the outcome of the second decision on the path. When there are multiple options for a decision, each decision outcome should be exercised before moving on to the next decision. Next, that is the fifth point. Continue generating new paths by repeating these steps. The most important outcome should be chosen first if new decisions are encountered. Finally, once all the decision outcomes on the baseline path have been covered, apply the same approach to all subsequent paths until all the decision outcomes in the specified code have been exercised. Advantages of basis path testing. It helps in achieving high test coverage by testing all possible independent paths, reduces the number of test cases required compared to other testing techniques, detects errors early in the development cycle, provides a systematic and structured approach to testing a test case design. These are the advantages. Next, and these are the challenges. Challenges of basis path testing. It can be time consuming for complex programs because understanding the control flow of complex programs can be challenging and also time consuming. The challenge is that it consumes a lot of time. Maintaining the test suite as the program evolves can be labor intensive. Ensuring that all paths are covered without redundancy requires careful planning. Requires a deep understanding of the program logic. May not uncover all defects in the code. Next, observations during basis path testing. Focus on testing boundary conditions. Ensure all decision points are covered. Verify the correctness of loop interactions. Basis path testing may uncover defects in the control flow logic of the program. It is a valuable technique for ensuring through test cases of complex programs. Next, best practices for basis path testing. Use automated tools to generate test cases. Involve experienced testers in the process. Collaborate with developers to understand the program's logic and design effective test cases. Regularly review and update the test suite to adapt to changes in the program. Combine basis path testing with other testing techniques for comprehensive coverage. Next, common mistakes to avoid in basis path testing. Ignoring boundary conditions and edge cases in test case design. Focusing only on number of paths rather than the quality of the test cases. Relying only on automated tools without human intervention in test case design. Not updating test cases as the code changes. Next, tools for basis path testing. Control flow graph generator, path enumeration tool, code coverage tools. Then, the limitations of basis path testing. Cannot guarantee 100% coverage, does not consider data flow issues, may overlook integration issues. Real world applications of basis path testing used in safety critical systems like avionics, automotive and medical devices. Beneficial in financial systems for ensuring accurate calculations and processing. Widely adopted in software development for testing complex algorithms and logic. Future trends in basis path testing. Integration with machine learning for test case generation, adoption of model-based testing techniques, continued focus on automation and tool development. Comparison of basis path testing with other testing techniques. Contrast basis path testing with equivalence partitioning. Compare basis path testing with boundary value analysis. Discuss the strengths and weaknesses of each approach. Next, the key metrics for evaluating basis path testing: code coverage percentage, number of test cases generated, defects found per path. These are the key metrics. Failure due to inadequate basis path testing. Present a case study where inadequate basis path testing leads to a critical software failure. Analyze the root cause of the failure and how it could have been prevented with better testing strategies. Discuss the lessons learned and recommendations for future testing efforts. Continuous improvement in basis path testing. Regularly review and update test cases. Incorporate feedback from the testing to refine the testing process. Conduct retrospective meetings to identify areas for improvement. Finally, the conclusion. Basis path testing is a valuable technique for comprehensive testing of software programs. Following guidelines and best practices can enhance the effectiveness of basis path testing. Continuous learning and improvement are essential for successful implementation of basis path testing. Thank you.